Why do we use random sampling in experimental design? And what do robot vacuums have to do with it? Stay tuned. I recently bought a Roomba, and it's really fun to watch. While some models have fancy AI that maps out your living room and all your furniture, the budget model I have solves the problem of cleaning the space in a less elegant way by randomly bumping into things and then turning around. While not entirely random, it kind of hugs the walls and corners sometimes. The element of randomness is key to ensuring that the robot covers the entire space. You see, the Roomba doesn't know what size or shape your room is. It doesn't know the layout of your furniture. It doesn't know when you've moved something into the middle of the room, like a chair. It doesn't need to. Randomness means it has an equal chance of going anywhere in the room. And if left long enough, it will eventually cover the entire space, no matter what size or shape. Randomness makes it so that all the other features that might impede its ability to vacuum the space are minimized. In an experiment, there are often many variables that you might be tempted to control. Let's say we want to look at the influence of background music on shopping speed at the grocery store. There are so many other variables that might make a difference. Maybe the age of the participants, the sex, the ethnicity. Maybe we should control for musical experience. Do they take violin lessons at some point, or do they play an instrument? Did they ever work at a record store? Maybe it would make a difference if when they were 11, they were riding to school on the school bus one day, listening to a particular song, and a bully threw gum in their hair, and that traumatized them. The individual life experiences of each of our participants can quickly add up to an unimaginably complicated mess of variables such that you can't control for everything. However, like the Roomba, it's randomness to the rescue. We don't know all of the variables that we might need to control in an experiment sometimes. However, random assignment to the experimental and the control group means that each of the variables are equally likely to be selected into one group or another. In this way, the randomness controls for all of the variables equally, such that with sufficient sample size, they are all covered. Just like watching the Roomba randomly bounce around long enough, it covers the entire floor. So next time you see a Roomba bouncing around randomly, think about how cool it is that it doesn't need any fancy map to vacuum your house. All it needs is a little time and a little randomness. Until next time, keep thinking.